of our I am Verna Felipe, the ICU-DDR Coordinator for Educational Programs and Regional Support. To know more about our organization, watch webinars, conferences and workshops, recording as well as access drug demand reduction related resources, we invite you to visit our website at www.icuddr.org. We are also inviting faculty members from higher learning institutions to sign up for membership. So some guidelines for today's event, so we make the most out of this workshop. First of all, kindly make sure that your microphone is turned off. And if you have questions during the course of Dr. Cosgula's presentation, type your question in the chat box and our speaker will address them during his presentation. The workshop is also being recorded and we will send you a copy of his presentation. We will also have a 15-minute health break in between the 3-hour workshop. Lastly, translations for closed captions for various languages are available. To turn on this feature, click the CC Captions icon at the bottom of your screen. And if it's not showing up, click the 3 horizontal dots or the More icon. Then turn on translation and select the closed captions language of your choice. So our facilitator for today has a PhD in engineering and is currently pursuing his second doctorate degree in social work. He is a researcher who specializes in adolescent substance use and a holistic system thinking approach to network analysis with the application of various engineering tools. His goal is to understand the factors influencing youth behavior and develop effective interventions that support community well-being. ICU-DDR is very pleased to have with us an expert who is generously sharing his expertise and time to facilitate this workshop. Ladies and gentlemen, I will turn the floor over to our facilitator, Dr. Janaka Cosgula. Dr. Cosgula?
Yes, thank you. Thank you so much, Mr. Vernon. So I really appreciate the opportunity. So I would like to use this opportunity to introduce you the basic concepts of R and RStudio, which is a really powerful tool in the current world where data is really useful. We can see the power of data, like AI, machine learning. They all are powered by data. So so this is just the beginning. So but after the introductory session, so there's a lot more that you can explore on your own once you have the basics. So I do not know the levels of each and everyone so individually, but I would assume that you have basic statistics knowledge. It's like Stat 101 is like already there, I'm assuming, in your knowledge. So with that being said, we'll get it started. And once again, thanks again for the opportunity. So we'll try to because this is actually first time I'm teaching after a while. I've been a a university teacher, but this is it's been a while, So I will see how far how fast I should go, and I usually work closely with students. So but in this case it's not that easy for us to do. But feel free to put the questions and I can answer momentarily. So first. We need to know what R is. R is a programming language that we can use to analyze data and visualize and then and manipulate data. So this is a really powerful open source programming tool. So some of you may not be aware of what open source means. Open source means it's freely available. No one has to pay any amount of money to use these tools, R as well as RStudios. It's all free of charge, thanks to a lot of volunteers who contributed their time and effort to build these tools so that we can use them easily. So it's really powerful because they continuously put on their effort to improve and make things better. And that is why it's a really powerful tool for everyday use for our data visualization, especially in social sciences domain. Okay, so yes, it has an extensive amount of packages and libraries. So these packages and libraries, they are actually readily made programs. So these behind these packages, there's like tons of coding. Somebody like a group of people who sat down for hours and hours and wrote those lines so that we just can write one single line and just get everything done, like a magic. So that's why these packages and libraries are really versatile for us to really get things done fast without knowing all the basics of programming. So, I mean, if you get into the basics of programming, you really need to know how to communicate with a computer. So basic, programming languages. We don't have to know any of those things. R, Python, all these programming languages, they made things easy. We just need to write a few lines with a lot of available features within these packages and libraries. We can easily use them with just few lines. So that's the beauty. So nobody has to worry about learning programming languages like Java or advanced object-oriented programming or something. So we don't have to go into that level. So these are really easy to use. So strong community support. So like I said earlier, so there's a big group of programmers who work on these tools as time permits to them. So they improve these packages and they make things like they add things. They bring more packages with more abilities. So things evolve. So what I teach you today, like what we learned today, could not be the most state of the art technology tomorrow. It's gonna probably change dynamically. So that's what we have to understand. But the basics that we learned today are applicable. So you can mainly just write your own simple code and if you have a data set of you're collecting data, so you basically can use that the data set to do the basic statistical analysis and then visualize them so that you can show it to people, present it somewhere, or get a publication somewhere, or basically use it in a way, whatever the way that you want to use it. And it also has a lot of flexibility because it can do a lot of things. So basically, anything that you want to do in this domain, basically in social sciences domain with data, other than qualitative data. So any quantitative data you can analyze here. And if the data is really messy, or if there's clutter, or if there's missing data, so you can really handle those things, and then do the analysis, and then visualize it. So there's lots of flexibility, lots of different tools, a lot of different choices that you have, through these platforms. So we'll get into some of them. And then integration. So you can integrate a lot of these tools with other things. So many other platforms like Python integration. Likewise, there's other visualizing tools, and there's other programming applications that you can connect with, like Shiny app and things like that. There's lots of things that you can do by merging R and R programming, RStudio, using RStudio into many different areas, many different other tools. So that's another advantage of knowing R. So mainly we use R for statistical analysis. So different kinds of statistical analysis, like basic linear regression model to almost advanced machine learning models, and even your own models that you can develop. But we'll start with the basics, and I think we'll stay in that level and then eventually you can build up to advanced levels. And then data visualization. This is actually a really important tool nowadays. Like people don't just plot X and Y, with some dots, and then they don't present that way. So there's lots of better visualization tools, and these people, like I said, the groups of these programmers, they have developed advanced tools that you can easily use to visualize them really nicely, so that people understand, what you are presenting, your story coming through your data. So that is another important aspect, which is really user-friendly in R and RStudio. And then data cleaning and transformation. So this is also another important aspect. Whenever you collect data is going to be messy. Data is going to be like missing. There's going to be missing data. There's going to be errors. So, and there's also going to be some sort of a different ways of transformation that you have to do. So all these things are possible to be done using R and RStudio. So what is this RStudio? So R is the programming language. RStudio is actually the GUI, like a graphical user interface. So this is actually, we call that Integrated Development Environment, IDE. So this is for us to use it, just with drag and drop, click, and then you can run it without going into the terminal, with the computer and, write your code like in a notepad. So that is a little bit not user-friendly. So all of us can easily use this RStudio, which is just a platform that we can use to communicate with the computer using R language. So basically we can have manage our projects and do the visualization and everything in a really convenient way using RStudio. We'll take a look into that. So let me stop sharing this and share RStudio. Okay, so this is what RStudio looks like. So I'm assuming that you have computers. So I would like you to get this installed, but I'll guide you through the process. But right now, just for you to understand, this is how it looks like. So console, and we have a console where you can type command, and then you can let's say like 2 + 2, and then it's going to show you like it's 4. So then that part is there. So where you can just basically type anything that if you know our language, you can just type it, and then you can simply get the output here. So this is a communication tool with the computer. So the console. And then you have the right here, you have the environment, so where you will have, your data. When you load the data, it's going to come here. So you're going to use it right here in the environment. So you can click on the data, and then you can take a look at it. So as we go, I'll explain all these things. So basically, what these the terminal is, where you can really do outside R if you want to create a directory or something. If you know that programming language, you can just use that to let's say communicate with the computer without using R language. This is basically the Windows based communication, not R. So and then it's going to show any background jobs. These things are not that important at this level. So console is important because console is going to show you where the outcome is going to be. And then the environment, you can see the history here. And then connections are also not important. This is basically database management. So this is, you're not going to work with a real-time database here. So this is, I don't think if anybody has to work with that. And there's tutorials. So you can click on the tutorials, and then you can learn a lot. There's lots of tutorials. There's a lot more things. I'm going to teach you some, but it's like an ocean. It's vast, the knowledge. So you can gain more through these tutorials. You can also just go to Google and search R tutorials, but this will also guide you through the tutorials. And here, when you create, a project directory, and then you will see all your data, it's being created, all the files you can see here. And then you will also see plots in this area. Hold on, maybe I should use this. Hold on. Okay, I should have done this. So this is the plot area. I should have done this earlier. So where you will see all the plots. So and then packages. Whatever the packages you want, you can click on them manually and install whatever is available here. But there's also other ways to install packages. We'll talk about them later. And then here is the help guide. You can get the help. And these things are not that important right now. So these are when you do the documentation. So we'll get into them later on, our markdown and things like how you really do reporting. So that comes as the last step. So this is basically the R Studio interface. So it's very easy to use. It also has this menu, so where you can let's say like new file, so like R script, and then all kinds of things that you can see here that you can easily create a new file, and then you write it, and then new project open, and likewise you can see lots of things can be done. Most of you are familiar with this kind of a menu, right? So we know like when you work with Word, Excel, PowerPoint, so it's very similar. This has like additional features, but we also don't want to know all the features, but we need to know the basic features that we need to run, and and then build the programs. So we'll look into those. See like install packages. So a few things that only few things that you're going to need. I also don't use all these things, so you don't have to be overwhelmed by all these things. We just have to know what we need as basics. All right, so go back to. Okay, all right. So those are the things I already explained for these slides to you. This is one example, like how to really load a package and then load a data set. So I can show you this. So since I have, hold on. Yeah, I just share. I'm going to share the entire screen so we don't have to go back and forth between these. Okay. I'm not really comfortable with Windows. Sorry, like I use Mac computer, so forgive me for this delay. Hold on. All right, so you will get this. So you can just simply, this is what I wrote. So you can just simply copy and paste, and then first you have to go to file, and you have to start a new project. So before you do anything, but for now, I'll just show you how this runs. Okay, so this is just to show you, the environment. So you have to install the library. We'll come to that, and data. So when I load this data right here, you can see it's being loaded here. So if I click on it, so you can see the data is being loaded here. So and you can just see this is where you run the code. You can just select it, and then right here, this is the run command. So again, like I'm going to go through all these things. This is just to show you, this is just it's there. Okay, so okay. Okay. And then the environment. So I explained, where the, when you load the data in the environment, you can see that. And then the plots. When we plot something, you will see that plot in that area, plot area. So I can also show you that, just to show you. I mean, again, like we are going to revisit all these things. This is not like the final thing. Just wanted to show you an example. So if I plot this, I just try to run it. So let me run. And it's going to show you a plot like here. So this is where the plots are coming in. See, X and Y axis. And so basically you will see right here. So let me use this annotation real quick. Just wanted to show you where these things are. So this is where you can see your data. And this is where the plot, like you can see, like when something is plotted. So you're going to see that right here. And then you're going to write your command, all those things here, right here. So then you can use this one button to execute. And then you will see right here, it's showing what the outcome is. Like I said before, you can also use this console to individually like enter line by line command and run it. But we usually have one file running here, with all our commands, and then you can run it line by line. So in order to run line by line, hold on. So you just have to go to the lines. So let's say this is the line. I think you can see my cursor. If you hit run, so it will just execute that line. And then if you come here, so if you hit run, it's going to do the same. So likewise, so click here, and you can just keep clicking until you see all the outcomes done. So this is what basically you have to do in our studio every day. So, but you also have to install some packages. I'm going to show you that also. Okay. Okay. All right. So let's get this installed. So I'll give you a few minutes to get this installed. Maybe I don't know if we should use the time during the break to do this, or however you want to do. Rona, how would you do this? Because I would like them to do some examples. So there's some activities. So I don't know how do you usually do this?
Dr. Kasgola, I sent them the link, so maybe we can give them like a few minutes so that they can sort of install it. And if they have issues, can they ask you questions about it?
Yes, I think that's better. Let's do that. So we'll give them a few minutes. So you can get there. Let me put this into chat, so then you can just click on the link, and then you can easily access it. So it's going to be right here. You have to go to the website and then select the correct operating system. I'll guide you through, but first let me give you the link. I'm
I
putting
can give
here.
them the link, sir.
Hello? Yes?
I can give them the link so that you can just focus on you can rest for a while.
Okay. Okay. I already did. Okay. All right. So
Okay, thank
it's in
you.
the chat. Okay. Welcome. Okay. All right. So please click on the link that I just gave you. And then you will see, you have to select your operating system. So for example, I'm going to do it right here on the screen. So you can see on the top right here, when you go there, so you will see like download R for Linux, download R for Mac OS, download R for Windows. Some depending on your operating system, so you can select. I'm assuming most of you have Windows computers, so you just click on this and then it will download. So So you can just get the base right here. Install R for the first time, you can see. Since you have never installed this, so you get the first the entire package. So then you will see download R R 4.4.1. That's the version for Windows. And then you click on that, and you will see the installation file. Okay, so now it's there. So you just click on it, and I'm not going to do it again because I already have installed it here. Just follow the instructions and just install it like you usually do in anywhere. So you just click next. You select the language, whatever the language that you prefer, and then select setup, and then you click next. And then you select the directory. I usually just keep this directory. I don't usually change it. Like C program files R 4.4.1. So I would rather just leave it as it is without any change. And then, I mean, in my case, since it's already installed, so I'm not going to proceed from here because it's already there. So, but you continue and then finish the installation. And then I'll tell you what to do next. I'll give you a few minutes. Okay. If you encounter any problem, just please let me know. Okay, you can let us know. Remember, once this download is done, you are not going to be able to see RStudio. So RStudio is a different application. So that's our next step. Okay, so this is just to install the R language, so that computer knows that that language. Right now, your computer doesn't know what R language is. So when you install R language, computer can understand the communication language. It's like you're teaching a new language to the computer. Through this installation. Okay. So, yeah.
Dr. Cosgola, there is a comment here that they have it downloaded and installed, but when they open the app, it doesn't have the split screen because I think they still don't have the RStudio. I'm gonna post the
Right.
instructions on how to up to download it, okay?
Okay, okay, yes. So definitely this is not gonna yes give you the RStudio. Yes. So now just Werner share the download link for RStudio. So please click on that link and then download and then follow the instructions and then install it. So you should be having RStudio installed there. So in your computer. So then you should see the screen that you saw on my computer. So you have to skip. You don't have to install R. So R is already installed. Okay. So you download and install R. Don't do that. Number one is already done. So you have to go to the second step. Install RStudio. Number two. Okay. So you can see download RStudio desktop for Windows. So in my case, this computer, you can select the correct operating system. So then follow the instructions and then you should have it installed. And then if you go to your search bar or the Windows, the taskbar or the command, your program bar, you will see you can search either like RStudio or you should be able to see that. So you just click on RStudio app and then you will see the same screen that you see here. Should I give you a few more minutes, Varna?
I think we're okay, sir, because we also sent that.
Okay, all right. So yeah, so once you have downloaded, you should be able to see the screen. So I'm pretty sure you are there. So let's proceed. Um, so let's set up the first R project. Okay, so let's do it together. So we have to go to like File right here, and then you click on New Project. Okay. And when you click on New Project, it will show you like this screen. It could be either like new directory, existing directory, or version control. So let's click on new directory because we don't have a directory, right? So let's start a new directory. And then it will come to this screen right here. So on this screen, you're going to select new project because you do not have a project yet. So you click on new project. Okay. So now here you can see right here. So it's given you a directory. So basically, like in my case, it's my user, and then desktop, and then our project. You can actually change this if you don't like to have your our project directory like on your desktop. You can have go to the documents and create a folder there and do that. Okay. So I'm just gonna give a name. So within this R project directory, it's gonna create a directory for this project. Okay. So all the files that you work on, let's say for your project, it's gonna be saved within this subdirectory. So this is the folder that you can find all your files. If you import your data, so if you export and if you save anything, your code files, everything is going to be saved here. So you don't have to manually set paths because now that you set it up in this environment, you set up the correct path automatically by creating a project. Okay, so that's the beauty. So we don't have to manually locate our project files and where the data is saved. So everything is going to be here. If you have your data file, we're importing from another place. So let's say you have a data file getting from another computer or another place. So you may have to make sure you save it right here in that same directory. Okay. So so now you can open in a new session. New sessions means it will open up a new screen, for R. So we don't need that. I'm not going to do that. So I'm going to create the project. So now it's creating the project. And once the project is being created, you should be able to see the name that you gave to the project right here on the top, right here. So on the top of the screen, you should be able to see that. Okay. Okay, so now you're there. So let's go to the next step. Yeah, so we passed these steps. And now we will try. So now what we are going to try is we just try to execute this command. Okay, so you can just copy paste it, or I think maybe Verna can give it to you.
I gave them a copy of your presentation, Dr. Koskula.
Okay, I can copy paste. It's right here. All right, it's right here. Or
I
you
also
gave them a copy of my presentation. Okay,
Yes.
okay, good, that's good. Okay, good. So then we don't have to do that. So we just have to, I mean, you can also type it, but when you type it, since this is the first time, you might make a mistake, right? So you can just copy and paste. So what you see is this is actually we are finding mean. MEN is mean, right? So we are finding the average of these numbers. Okay, so this is actually an array, like in one-dimensional array. So of the numbers, so we have just these numbers 1, 2, 3, 4, 5, and we just find the mean of these numbers. So and then if you just have to enter, right? So you can also change it. Let's say if you want to go back and just change some of these numbers, let's say like 3, 4, and then put like maybe like 10, and then you find the mean. It's going to give you the mean of that array, right? So this is how you can do it. I can copy the PDF.
Yes.
Okay. Okay. So I can hold on. I can copy paste here, right here. So now you have it on the chat. Okay. So go to the chat. It should be there in the chat. And simply copy paste, and then you can also change these numbers and see if it's changing. So this is a place you can just like type something that if you want to quickly find an answer, you can just type it and then get the answer. But if you have a set of commands, like a long set of commands with different conditions, this is not the best place. Okay, so we'll get to that step pretty soon. Let me know if I'm going too fast. Okay.
Dr. Janaka, there is a message. It shows that when there's a warning message, her graphics is not supported by the version of RStudio.
Oh, okay. Mm, okay.
Well, sir, while you're looking into that, for all our participants, the PDF file is on the chat box. I am trying to convert this to Word and will send it to you in a minute. Thank you.
Okay, I can also share the PowerPoint presentation one. You don't have to worry about that. You want me to do that? I can do that.
Oh, thank you so much,
I
sir.
can put it in. Yes, yes. You don't have to do that. But I think this problem. The warning message. Our graphics engine version 16 is not supported by this version of RStudio. So so plots will be disabled. So I don't know what this causing. So, but I can take a look at it. Okay, just give me first. Let me give you this PowerPoint presentation. Okay, so I'm gonna copy.
While you're doing that, maybe sorry, sometimes it might actually be that the graphics that are in the graphics are not compatible. So maybe it's like kindly make sure that it's for your right hardware. If you're using a Mac or a Word or a Microsoft, the Windows, sorry. See, because I'm a Mac user. So if you're using Mac or Windows, you have to make sure that your R and RStudio are both for the same. Okay, let's look into it.
Wait, I'm trying to get you a copy. Just wait. I need to save this as. Hold on. Please. I am having a hard time with my files. So because I have three, I prepared in all three files, so I just want to make sure I'm giving you the right ones. Okay, all right.
Take your
So
time.
yes, it should be. Yeah, I'm sharing it right now. Okay. So you have my presentation. You can open it up, and then you should be able to go to the corresponding slide. It's actually slide number 17. So sorry, the previous one is going to be, I think, 16, right? Yes, it's going to be 16. Yes, slide number 16. Okay. So regarding this problem, where the issue that you're facing um, with this warning message, so you might have to reinstall. You have to make sure you have the latest R version. I don't know if you selected a different version to install, so that you make sure that, and if not, it could be another compatibility issue. So I'm not so sure, why you are experiencing this. But I also have a MacBook, so I know my other computer, I had problems yesterday. So I never got this problem. So I'm not so sure what's going on. But usually, like what it's saying is, like, you need to check if you install the correct version. So you may have to uninstall what you have right now, and then go back in there and then find the latest version. Make sure it's the latest version. If you go to so
Dr. Cosgola.
RStudio, yes.
I will take care of her. I'll send her a message and then show her the exact link, and then so you can go back to your
Okay.
presentation. Thank you.
Okay. All right. Okay. So then let's continue.
Yes.
Okay. So now you can actually go back to your IDE. So we were able to run it here. So now what I want to do next is actually create a new file. Go to New File, and then on the top you will see our script. Okay. So File, New File, and then R script. Or you can simply, you can see right here on the top of the screen, top
Dr.
left.
You haven't shared your
Yes.
screen.
Oh, I haven't shared. I'm sorry. Okay. My apologies. All right. So you have to go to Files, New File, and then R script. That's the top, like the first in the menu. So you can see New File and then R script. Or you can click right here. You can see right here on the top left. You click on this drop down and you see R script. Either way, it's gonna give you R script file. So when you click on that, it will open up this top pane where you have this script document that you can edit. Okay. So you can actually just copy and paste your previous command here, and then run it here also. Just click on here and then run. You will get the same thing. And then you also can try this. So just to check. So this is actually a data set. So I'll show you that this is so this is a data set that's already inbuilt into R. So you can just type data and then load it. And whenever you use this sign, you see like this pound sign, when you use it, so it's going to be a comment. So this line is going to be omitted. Okay, so whatever you type here, you can type anything that you like to type, because it's not going to interfere with your program. So it's a good practice to keep your notes, right? You know what did you write? What is this line? What is this section? What is this program? What is this function? So you can always use this sign and then type your notes. Okay, so in between your lines, in your commands. So right here, so this empty cars is a data set that's already inbuilt. We don't have to import it or export it. It's already in there. So if you just run this, you should be able to see that right here on this screen. Okay, empty cars. So, and then if you summarize it, you should be able to see a summary of the data. See? So when you look at the right here on the left-hand side, if you look at the screen, so you should be able to see some information about your data set just to validate. Okay. So for example, if you come here, so so you should be able to see like right here. So this is 32 observations. That means you have 32 records there, and then there's 11 variables, right? So so there's 32 observations of 11 variables. So you can verify that actually by really observing the data. I'll show you how to do that. Okay, so you just click on this. Okay, you come to the environment. You see empty cars, the data. If you click on it, it's gonna open up another window, which is showing you the data. So see, this is what it is. So you can see like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 11 of them are available. So you can see there's 11 columns available, and then 32 rows available. And it's also visible here at the bottom. So it's just giving details about some cars, right? So the miles per gallon, number of cylinders, and all kinds of information is given here about each and every car. So this is how you can simply run, and then also use this command to get the summary of the data set. So it's going to display the summary right here. So you can see, you run summary, you should be able to see the summary of the data set. It's going to show you, let's say for example, MPG is one variable, right? You see, so the first column, right? So we can see the minimum, and then the first quantile, median, mean, and then third, then maximum you can find. Okay, so all this information you can find just by summarizing.
Dr. Kasgola, it says that there's a
Yes.
lot of comments saying that their environment is empty.
The environment is empty.
Yeah, and then the empty cars doesn't appear on the right side. So I think if you guys look, there are 2 tabs. Maybe that's it.
Yeah. So okay. So I'm reading the comments. So empty car does not appear. So did you have to run the command? So I don't know if you did that. So you have to either select this, or you have to go to that line and then just run it. So yeah, then it should appear on the right hand side in this environment. So make sure you are in the correct tab. So once again, so it's right here.
Sir.
Yes.
Okay. So
Yes.
there is like Munir shared his screen. So it's the same for the first one. Have you tried running everything? And there should be a tab that would appear.
Okay. So
It's in the
I can see. Yeah. So let me take a look at it.
Thank you.
Welcome.
And guys, if we missed some of your questions, kindly type it again in the chat Sorry, I was like looking into the other um, technical issues. Thank you.
Okay, so
Sorry, go ahead,
yeah,
sir.
so yeah, so so now I'm not able to see this. So so she's shared the screen, so she ran it, right? So I can see all her, like, that she got the summary, but she's not able to see the environment. So I don't know exactly what's happening. So you may have to restart R, because this is not really usual. So it appears like, can you check if there is any errors? The bottom of the console, if you see any errors, like, can you scroll up and see if there's any errors? If you scroll up, in the console, go back to the history and see if there's any errors that is showing you. So you can also try to do this, like, for example, so let me share my screen again. So once you load the data, so you can do, like, let's say head, you type head, and then you put within parentheses, you just type 20 cars. And then it should show this. So see if you can get that. Let me look at your screenshot again, because it looks like it's I I don't know what exactly is happening. So I'm assuming that something is wrong in the environment. So, but if you do head, and it should it should at least show these first few rows. Okay, so let's proceed. Can you try that and then let us know if what's happening? And then we are going to proceed. So since it's also connecting to the network and extracting it, so that could also be an issue. It's not like really um, uh, in your local, folder, right? So that could be also an issue. So, but I have never experienced it. So the next thing, like, we already learned what the environment is. So where some of you cannot see, your data file, and then files plots. So we saw that already. So plots right here will appear. Earlier we saw that, and then files will be, visible. So when you import files, and also maybe when you save the data, you will see that. So I can show you that. For example, if I save this script, so if you click on File and then click on Save right here, And you can see you are already in the correct directory. So you can just give a name like my first script. Okay, and then you can save it. So once you save, you can see when you come to this file pane, right here this side, you can see my first script. It's being saved. So you can easily access just by clicking on it. So you just can click on anything here, and you can see whatever you have, within your directory, project directory. Okay. And then, so now the next step is to to learn how to install a package. So that which is important. So there's multiple ways of doing that. I'll show you. So like I said before, these packages are nothing but those inbuilt programs that we can easily use within one command or two. Okay, so let's clean all these things, and I'll show you how to install packages. So simply you have to type, let's say, like for example, like install, and you don't even have to complete. So you will see it's going to automatically show up, install packages. So click on the first one, and then within parentheses you have to give the name. So in this case, we have BPLYR. So it's one popular package that we use regularly. Okay, so so within single quote you type that or copy paste, and then you have to run it. So so right here, so you click on this, and then you run. Okay. So when you run, you will see on the console, there's multiple things it's doing. So now in my case, since it's already installed, I'm not gonna it's not gonna run everything for me, but it's already done. But in your case, it might take a little time. Okay. So this is how the installation is being done in one way, but there's also other ways of doing it, multiple ways. I think for now, this should be enough for you. I don't want to confuse you with multiple things, but this is like the standard way of installing packages. So whenever you work on a program, you may need to install some packages like this. R also has a base package, so which is actually the base programming language where you can do many different things, like that's these calculations. Remember that mean function that we typed earlier in the console? So that's coming from the base package. So that computation. So likewise, there's also some base commands that we can use without installing any package. But any additional advanced features like visualizing tools and analyzing tools, you need to install packages. So where they have additional functionalities. Okay. So this is how we install. Once installation is done, you don't have to really reinstall this again because it's going to be there. Okay. So when you work on another project, so you don't have to install this again. It will automatically added. It will be automatically added to your environment, but you can always go back and check if it is the up-to-date package. So you have to check for package updates here. So then it will show you, like in my case, all packages are up to date. Okay, so in order to do that, you have to go to Tools and then check for package updates. So from time to time, it's better to update because sometimes these programmers, they change, their program. So sometimes there could be some incompatibilities because you might be using an older version of package where things have changed. So when you have to use that package with the combination of another package, so then there could be some compatibility issues. So it's always best to maintain your R environment up to date. Okay, so as much as possible. So once the installation is done, so we are going to load it. Just because it's installed, it's not going to be there. So you just have to type library, like you go to the library with books, and then within course, you just type the same name. Sorry, it's right here. Within course, you just type it. So, and then you run it. Now it's loaded. See? So now it's being loaded, and now anything you do, anything that's within that package can be used. Okay, so this is how you install a package. Very simple. Just two lines. Any package. There's nothing new for other packages. This is the same process. Okay.
Dr.
All
Kusgo,
right. Yes.
question in the chat.
Oh, okay.
Thank you.
Okay, I'm checking. What? So uh, this is a package like that they prepared to do multiple, program languages. I can see. Is there another error? Okay, what is this error? Saying automatic, trying to read automatic trial. I don't know what exactly you're experiencing. So are you not able to install the package? I'm not so sure what exactly.
Oh, now they said it's working.
Oh, okay, okay, okay. So yes, and then if you're asking the meaning of DP, no, that's not a like there's no like a regular. I mean, it's like it's like dplyr, like applier or something like that. So basically, it's just like people use their even their first name or last name for packages. So some packages have meanings. So some packages don't have meanings. I mean, because these are being developed by sometimes like people, individuals. They just use their name. Okay, good. I'm glad it's working now. Okay. All right. So let's proceed. Um, and then so yeah. So anytime you need to get some help, so you can access the help files and documentation. And about Markdown documents, we'll come back to that later. So it's basically like an easier way of running the program and then getting also like a nice documentation done. So that we can come back to that later, but for now, we can keep it aside. Okay, so you can also customize your interface if you don't like the way it looks. You can change the color, the appearance, different things. So you can just go to Tools, Global Options, and Appearance. So let me show you that a little bit. Tools, and then you see like that's the last thing. See, Global Options, Tools, and Global Options, and then you see Appearance. So that's how I have changed my appearance. I mean, your one looks like um, probably like white background, right? So mine is different because I changed it already. Like maybe yours looks like the traditional one. So you can change it. You can see like themes, different themes that you like. You can just select them and then apply. Okay. So anything that's convenient for you. So these things are not really important, but maybe for some of it's important, especially if you sit on the computer, sit in front of the computer for a long time. So you may need these things. Okay. All right. So that's one thing, and then um, yeah. So you can rearrange the panes by dragging and dropping them to preferred positions. I mean, these are like standards, like, usually many people keep things this way. I mean, I have seen many people just keeping the same, like, setup this way. But if you want to drag and drop, you can do that. I mean, if you want to minimize and maximize some of these things, that also can be done. See, if you want to see the entire, like, console, like, or maybe scroll it up and down easier, you can use this maximize, minimize button. Okay, and the same thing can be done here. If you want to type a lot of code right here, programming, right here in the script, so you can maximize that whenever you have to do that. So everything else, all the other screens are also the same. Okay. So yeah, if you want to set up keyboard shortcuts for like running or anything, you can also do that in these tools global options. I can quickly show you that also. I don't think it's also that really important, but I can show you that. Um, so right here, if you go to chord, and then you can see key bindings, modify keyboard shortcuts. So you can change your keyboard for shortcuts, whatever you prefer. You can change them to run a command, copy paste, and things like that within the R Studio platform. You can make those changes. Okay. Again, let me know if I'm going too fast. Okay, I don't want to go too fast, but I'm assuming you are really following me. And then so basic commands we already ran. You can just print hello world and just see what your outcome is. That we don't have to look at it again. We already did that. So in order to run a script, I showed you, how to do that. So you can do Control Enter in Windows computers, and then Command Enter in Mac OS. Okay. So or else you just simply hit the Run button. Okay. You can use this Run button right here. So you don't have to do that. And you can also see it's Control Enter. When you do Control Enter, it will just run. All right, and then so these are some basic arithmetic operations. You can just try, yourself. Very simple. I can just show you once. Maybe we can just try all of them. Simply copy and paste. Now that you have my PowerPoint presentation, you can just copy and paste and then run. Okay. Remember, these things, you don't have to bother about them because it's not going to be read. Okay. The program will omit, so you don't have to worry about those things. See, 5 plus 3 is 8. 5 minus 3 is 2. 5 times 3 is 15. 5 divided by 3 is 1.6. So you see the outcome in the console. Okay. So you type your code here in the script, and the console is going to show you the outcome. Okay. You can also type your code in the console, but it has to be line by line, or else you can just copy and paste the entire thing, and it will show you that also. So the script right here is there for you to just easily, conveniently type your code without accidentally clicking enter and just running everything. So console is not there for you to type your code, because if you type one line and enter in the console, it's going to run. That's not probably what you want to do. So that's why you probably have to use this script, this window to write your code and then execute it. Okay. Yeah, you can try these things. I don't think if you have to spend time doing that, but let's do this, because this is where you assign a value to a variable. So let me show you that. Okay, so basically, hold on. So you see this arrow and X. So here X is some sort of a variable. So that variable is that you can call that later. Okay. So and then you see 10 with this arrow. So arrow means X is equal to 10. So or else assign the value of X to 10. Okay. So the same Y is equal 5. So if you run this line, you can see right here on values. If you go to come to the environment, I can show you. right here. So you will be able to see x equals 10, right? See the value. And now, if I run this line, y equals 5, right? So now it's showing y equals 5 here in the environment 10. Okay. And now, if we add x and y, it should give us the results as like 15, right? So let's try to run this line and see if it's giving us 15. You can see the result is 15, right? So in values, you can see it's 15. If you want to print it in the console, you can just, let's say, for example, just type result and then you run it and it will show you. Or else you can also say print result. Okay, that will show you. It's going to print either way. So, but you can see the values here and in the environment. As long as they're not like, arrays or vectors, that's going to be a little bit complicated. Okay, so how is everything now? So any questions? Werner, is everything fine with the chat?
Yes, I am.
Okay. Okay, good. Okay, so let me continue then. Okay, so yeah, so we have an activity. So let's try this activity. So it's actually, I put them into 2 slides, but I think you should be able to handle it. So let's do this first activity for you. Okay, so so we can see this is where the script begins. Okay, you see like R right here. So anything below that, it's your script. Okay, so first 2 lines, you are actually assigning values to the variables. A is -10, and B is -2. Okay, and then you basically like performing these arithmetic operations, and then you're printing them. So let's try to do this in your environment and see where you're heading. Okay, so it's very important to get hands-on experience with these commands before you go into the advanced levels. Okay, so I don't want to overwhelm you with too much information today without understanding the basics. So I think in order to get the best out of this this workshop, it's better to do things as we go. Okay? So that's why I have this activity. So I don't want you to do all of it, but try to do that. But I'll explain what all these lines mean. Okay, so you can focus my screen for now, and then I'll give you a few minutes to do the rest. I'm just going to clear all this because it's easier. Okay, so I'm going to clear this also. Okay. All right, we have a nice looking environment now. It's clear. And then let me get these things right here. Okay, so now if you can take a moment to look at my screen, I'll tell what we are doing here. So first we are assigning variable values. You, instead of arrow, you can also use equal sign. Okay, so they are going to do the same thing. You will be fine. So, but standard practice is using an arrow in R, so that's I'm using the same. So so we are assigning A as 10, B as 2, and then you add, you get sum, difference, product, quotient, and then you print. So here, if you look at one print line, command line, you can see paste. So this is actually a function, in our base package. Okay. So what does it do? So it's basically adding 2 strings. So like sum is actually like you're just telling sum is sum. This sum is actually right here. It's a variable. But right here, what you see in yellow color is not a variable. It's just a string or something that you type. So within this quotes, you can see these quotation marks, single quotation marks. You have string, and that or you can type your name. No, it's still it's going to stay. I mean, obviously it won't make any sense, right? So still it will execute without any error. So, but it's not Janaka. It's actually sum, right? So it's sum, and then comma. You actually type the variable name. So if we execute this, we'll see what it's going to give you. Um, so if I say print, it's actually going to print sum 12. So if I say here sum is, and then it's going to print sum is 12. So basically, this paste command is doing a thing called concatenate. So which is combining two strings. So converting this variable into a string, and then it's adding it to this string. So these are like two strings adding together. Okay. So that's what this function does, just for you to understand. It's always good to know what's happening without just like simply like using a function. If you have a basic understanding of what it does, it's it's better. Okay, you don't have to know everything, but at least the basics are important. Okay, so now I'll let you run this in your environment, taking a few minutes. Let me know if you run into any issues. Okay.
Okay, so there's a question like they have been typing the code but they don't see anything on their global environment. They might
They cannot say anything.
Yeah, so I think they have to
It says,
actually have to go back to the loading of the R script creating project probably.
yeah, I think so. So you have to follow the steps properly, and set up the environment properly. With the project, start a new project, and then you don't have to install any packages, because again, like I said before, this is just like we are using our base package, functions. So you don't have to have any package installed here. Okay.
Dr. Cosgola, it's 9:28 on my watch. Can we take a 16-minute break so that people can catch up and you can take some rest? And if you guys have
Yes.
questions, put it in the chat and I will try to respond. And if I don't know, I'll endorse you to Dr. Cosgola. But for those questions, keep them coming.
Okay. So did you say that it's better to take a break right now?
Yes, sir. So let's take 15-minute break so that those people who are having problems, they can catch up. Is that okay?
Yeah, yeah, yeah. No, like 15 minutes break is okay. Is that fine?
Yes, yes, please. Thank you.
Okay, welcome. So I'll just come call back in 15 minutes. So like I'll is that okay, or should I stay on the phone?
You can call back after 15 minutes, sir. That's okay. We'll watch out
Okay,
for you on
okay,
your end, sir.
okay, all right. I'll call you back in 15 minutes. Thank you.
Uh, okay, guys, I'm reading your messages. Let me just respond to them one by one. Give me time. Uh, yes, ma'am. For those who have questions, kindly type it in the chat box. Hold on a second, guys. I know that your messages are coming. Let me just wait. Okay. Um, um, results, some, increase reference, Oops. Mm. Okay, guys, are there still questions that I was sort of not able to answer? And I love it that you guys are helping each other. Thank you. So it takes practice. I know that this can be overwhelming because like I had it in my first year of PhD and I want to quit. But hang in, we'll get it there. So we still have 2 more minutes. So if you guys want to go bathroom break or coffee or just walk around or practice, we'll be here and let us know if there are questions we were not able to answer. Okay. Oh, hold on a second. I need to.
Okay, can you hear me now?
Yes, perfect.
Okay, perfect. All right. So let's continue. First, I want to share my screen. Um, okay, where did you stop? Right here. No. Okay, so the activity, I hope you were able to get it done, but feel free to let me know if you have any questions. But we'll be doing a lot of activities like this, so you might repeat these things, so you don't need to delve too much into it right now, and worry so much about it if you don't understand still what these things are, and if you're trying to wrap your brain around. So don't worry so much. We'll proceed. Let's proceed and then see what else we have to learn here. So um, usually I explain how to install packages. This is coming from this a thing called this CRAN. So it stands for the Comprehensive R Archive Network. So that's where all the packages are being deployed by all these programmers. So it's a repository where we can access anytime that we need to install package. So when you install it, it will make a copy in your local environment, and it will start communicating with your computer through that programming language. So so we already talked about that. So ggplot is one popular package among many others. And so similar to that dplyr, so where we use it for data. Um, um, and we use this for um, visualization. So ggplot is a really powerful visualizing tool that you can use to create different kinds of charts, plots, and really amazing visualization. And then DPLY. So we said like it's kind of a data manipulating and transforming package. We talk about that later more. And then you also have tidyr. So this is where you can use to tidy, like up data and also reshape. So that has lots of tools that we will go through some of them. Like I said before, these packages are vast. There's a lot that you can learn. There's even I don't know everything that it can do because I have never used everything. So because I never wanted to use them. So there's lots of things, and also you don't have to remember everything, memorize everything. So whenever you have to use a package, you just go to the document. If you go to CRAN, and you will be able to see the package PDF containing all the user manual. So it will show you all the functions that it has and also some examples. So it's really easy to use them. So like I said before, they have done all the work. We just have to use those few lines of command to get it done. And that also you don't have to memorize. So that's not required. See how easy it is for us to get things done here, right? So so that's why I'm really highly recommending you to just be familiar with these packages, not to memorize, but be aware what it can do. So for example, ggplot can really plot things multiple. If you know that, that should be enough. Then you go to the the package, the guideline, the user manual, and then you can really find out what you want to do. And then Shiny, we are not gonna touch that. This is basically for people like me, engineers, building apps and interactive environment. So you don't need to worry about that. You don't have to do that at this point. So and then we have another activity. So installing and then plotting something. Let's do this together. So this is also not difficult. It's very simple. We are also, again, like here, also we are using another inbuilt data set in the R environment. So let me clear this. All right. So first we have to install the package, right? So that's why you copy paste, my code from my slide, and then you paste. This is right here into the script, and then you run the first line, and then you will install ggplot, and you can see ggplot is being installed. It might take a while for you to install because it's the first time, right? And then you load it using this library command. So you can see I'm not using the code, right? You can either use that or not. That's fine. Still, it's going to run. There's some flexibility here. Okay, so earlier I used it, but now I'm not using it, right? So that's not really 100% required. But in here, when you install packages, it's highly recommended to use it, right here. So when you call the library, you don't really have to use it, but still it will recognize. People have, the developers has, whoever did this, they have program it that way to identify what the correct package is. And then same goes here. So we are loading the MPG dataset, which is inbuilt. So just run it, and then it's going to be loaded here. And then ggplot. So this is, we will talk about this extensively down the road later on. But for now, just to show you what this means, if the ggplot is, this is actually function, inbuilt function. So when you call this function, which is within this package, now we just installed ggplot2. So in this function, we are calling all these arguments. So you can see the first argument is MPG. What is MPG? It's the data set, right? So we have to give what the data set is. Identify the data set, then put a comma, and then we have to identify this aesthetic. So we have to identify what x-axis and what y-axis, and those things we have to identify. So x-axis is one variable here. It's think it's display or something. I don't know what it is. Displacement or something. And then y-axis, it's a variable name, like how whatever is in this MPG data set, something that they fabricated. Okay, so y-axis is um, highway or whatever. So that's, you have to identify them. So this is aesthetics, and then we also have to give the identify. So those are the things that we have to put in the ggplot, and then plus point, geometric points. So when you call this point, this is actually going to create a dot plot. Okay, so it's like a scatter plot. So if you run this, you should be able to get a scatter plot with the x-axis of display or whatever, and then y-axis of highway. So you can actually see what this data is. So you can see it right here, displacement or something. I don't know what it is. Model, year, cylinders. So this is, yes. I think it's a car. Again, it's a car-related database. So, but it doesn't really matter. So we just use some sort of a data set just to understand what it is. So you can see now the plot is going to appear right here. So on the right hand side, the bottom. So once you have the plot, you can either right click on it and then save image as and save it. Again, it's going to save right here in your directory, your project directory, or else you can also do this export thing. You see, click on right here this export, this drop down menu. So where you can see save as an image, save as PDF, or copy to clipboard. If you copy the clipboard, you can directly paste it in Word. Okay, you just you can copy and then you can just go to Word and then paste it. You can do that. Okay. All right. So simple. I hope you can replicate this. So now let's focus on basic data types and structures. So when we work with data, we need to understand what different ways of storing data. The computer is pretty smart, so it can store data in many different kinds and in many different ways, in many different structures. Okay, so you don't have to understand all these concepts, but we need to know a little bit of basics. So you don't have to know like all of them, different arrays of the data, how we store. Those are the fundamentals of computer and engineering and programming. So that's not required, but we need to get the basics. So different ways of storing data, like as vectors, matrices, lists, and then data frames. So mostly we are going to use the data frames because this is in fact indeed a data frame, what we have here. So this data is coming as a data frame. Okay. So which within this data frame you see all this data. So you get like head, and PG. It's going to show you the first 5, 6 records, right? So now we can see if you go back to the environment, you will see there's 234 observations of 11 variables. So this is basically we have 11 columns and 234 rows. So if you try to visualize what it is, so it's something like this. So basically it has a 2 by 2 structure. So let me explain what it is. You may not understand what I'm talking about right now. I should have the whiteboard, right? Okay, I haven't done this in a while. So I'm trying to get the whiteboard, but it's not available. Never mind. So let's do it in Word. Okay. All right. Okay. So for example, let's get a table. So I'm using a table, to show you different, structures. So let's say we have only one column, okay? One column and then 10 rows. So one column is like in columns, usually we have variables, right? So for example, let's say if you go back to our this data set, let's say it's just the first column. So where you see the manufacturer, right? It's Audi, and that's all. So we should be able to see just that. Okay. So something like this. Okay. So right here you can see this is just like one column. So we call that a one-dimensional data structure. So this is basically nothing but like when we come here, they are the vectors. Okay, vectors are like that. Okay, so but the vectors contain the same type of data. So for example, if you come here, so this is going to be like, let's say this. First, we have to name the column, right? Let's say it's the manufacturer, right? And let's say it's Toyota. And likewise, we have other manufacturers here, whatever, however you want to put forward. And so it has to be only manufacturer. You cannot have, let's say, for example, the miles per gallon, MPG. You can't do that, 43. That's not possible. So that's not a vector. So in that case, okay. So this is a one dimension, vector. So you can see, you can either have it like this, so one column, or you also can have it, in the other direction. For example, you can just transpose this. So where you have one row and multiple columns. So this is a vector. Okay. So we save this kind of data in a one-dimensional environment. Why did they say one dimension? Because it only has one dimension. So it only increases in the rows. But when we talk about two directions, let's go to the next one. So now I'm going to have columns also. So okay, let's say 5 columns and then 10 rows, whatever. Let's say like 20 rows. Okay. So now if we do this, you will start seeing 2 dimensions. Okay. So now you can see columns. There's dimension here in this direction, and there's also dimension here. This is 2 dimension. Okay. So now in our data, so right here, we come here. They are matrices. Okay. So now we introduce those 2, and then matrices also can have only same kind of data. It cannot have different kinds of data. Okay. So let's say if it is just numbers, it has to be just numbers. So you cannot have multiple types of columns in matrices. For example, right here, so this column should only contain let's say strings, names or something like that. You cannot have different kinds of things. Okay. Yeah. So when you have a vector like this that has multiple types of data, it becomes a list. Okay. A list is a complicated thing. A list can contain many different objects. It could contain another list, another array, anything. Okay.
Dr. Janaka?
So yes.
You're not sharing your screen for this? Oh, sorry. No, we can see it now. Thank you.
You can see it now, right?
Yes, yes,
Okay, I'm showing my Word file. Are you able to see that?
yes. Thank you.
Okay,
Sorry.
okay, good. Welcome. Okay, good. So, when we have multiple kinds of data, for example, let's say like instead of like, just manufacturer, we have like, many things. The manufacturer, or let's say like the year, and then maybe let's say like MPG and all that. So then you will also see like, different, like let's say year 2018. And then here you will also see like, the miles per gallon, like, 34, something like that. So then this becomes a list. Okay. So that you don't need to think about all these things, because these are like a little bit advanced, for you to work with all these things at this point, but just for you to understand these things exist. That's more than enough. And then a data frame is the main important thing for you to understand. So as I said earlier, matrix, like, we, even though we do have multiple columns, it cannot contain like different kinds of data. But when we have a matrix like this kind of a structure with different kinds of like, data, let's say like the first column, we have, the manufacturer, and the second column we have year, right? Here. And likewise, all the other columns also have different kinds of data, right? So in that case, this becomes a data frame. Okay, so that's where the data frame comes in. So if you go back to this example, this data is actually observed in a data frame. So pretty simple. So you always, most of the time when you work with data, you will have a data frame. I think that is the most important thing that you need to understand. Okay. Other things, they are not that important, but it's better to be aware that those things exist. So I have some definitions and some examples, how to create a vector. So you can just copy and paste and then try to create this vector and see how it looks. So basically, it's just one dimensional. So if you run this command here, so let me show you. We'll just run this. So it's a vector. See, it has numbers going from 1 to 5. So it's one dimensional. You can also print it here in the console. Same thing. Okay, so this, you could have any number here. Something, and then you run it, and then it becomes a vector. So this is a vector. Likewise, you can also try other things, this matrix. So matrix has rows and columns. Remember, in our tables in Word, we had rows and columns, right? So you have to assign how many rows and how many columns are there, and then you have to give values, to fill the values for each row and column. So that's what it's doing here. So this is actually not that important. So you just need to be aware this exists. You see, there's 2 rows and 3 columns. So this is the matrix because we assign it as 2 rows and 3 columns. Okay. And then list. Sorry. List. So you can see list right here. List is actually like, you can see it containing so many things. Multiple things can be included. So for example, in this list, we have, the first item, first thing in the list is, the name, John. And then the second one is age. And the third one is indeed a vector, right? You see, it looks like a vector, right? See, it's a vector. So inside this list, we also have a vector. So if you run this, it will generate a list. And then we can also print it and see what it is. So you're going to see, this is the list. The first thing is name, John, and then age, 25, and then scores of this person, this John's scores, there, in vector form. Okay, so within list you can have vectors also. And then the next thing is data frame. So we already created a data frame. So I mean, we saw a data frame, but we have not created. Let's try to create a data frame now. Okay. So this is a data frame. So now you can see this data frame has 3 columns, right? So you can see the first column is name, and it has values. See, this is actually a vector. So of values. Okay, so it's giving John and Jane. So John has an age 25, and his score is 90. And then you have Jane here. Jane has score of age of 30, and then score of 85. If you run this, it will create the data frame, and then we should be able to see it right here in the environment, and we can also print it in the console. There we go. So, for example, if I click on this right here, data frame in the environment, you can actually see it on the screen. You see, John is 25 years old, and his score is 90. And we can see that clearly. And again, we can also print it in the console. And just like, run it. You can see it also in the console. Okay. All right. I think that should be enough for you at this level. Yeah, I also have included some additional things here, but I don't think if you have to know all that. I mean, I probably would skip them for now, because just in case if somebody is interested in some advanced things, so you can come back and look at it. But I think that what we know right now is more than enough. Okay. So I do have. Actually, I have repeated the same thing for some reason. I don't know why. I think it's probably the same thing. Must have made a mistake. My apologies. But I have an activity. So let's do the activity together. So why don't you also copy and paste this, and then I can explain what it does. Okay. So there's multiple activities that I have created. We don't have to do all of that, but we'll do at least a few. Okay. Okay. Once again, I'm just going to clear everything. Okay. All right. So we are creating a numeric vector. So this is a numeric vector. We can also create a character vector. I know I have that example, but we don't have to do that now. But let's do this for now. So now you can see in the environment it's showing the vector, right? You can see that clearly with the numbers. Okay. And then this is the command to create a matrix with n rows is 3 and n columns is 3. So 3 times 3 is 9. So you need to have 9 values here. So this 1 colon 9 means it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. Typing 1 to 9 like this, or 1, 2, 3, 4, 5, 6, 7, 8, 9. It's just the same thing. Okay. So you can you can just do however you want to do, and then you can write. Okay. And then you should have the matrix. So you can see in the matrix you have all these dimensions. Okay. 2 dimensions. It's 2-dimensional. And you can print it and also visualize like I did earlier. Okay. See, this is the matrix. You can click on it and take a look at it. And then you have list right here. So when you have a list like this, I think we created this earlier also. It's going to have all these variables. So you can also go to the data and then click on this drop down, and then you can take a look at what the list contains, or else you can just print it. and then data frame, like right here, the data frame that we created earlier. It's pretty similar, and then you can look at that. So you can print all these things in the console using this print command. Okay, so now you can check, and make sure it's working for you. I'll give you a few minutes, okay? Okay, so I hope you're doing fine. So like I said before, let's say you don't have to type all these things. Okay, so if you're typing like 1 to 5, you can just say 1 to 5 like this. Okay, and then it should be the same thing. See? It's adding the same thing. And then here also, you can do the same. You can either have 1 to 9, or you can type 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. And then it should work. So I think that's enough. Activities, maybe we can take a look at the next activity if it's doing something different. Yeah, I think I would recommend you to just try these things. So this is adding 2 matrices. Let's try this also, how to add 2 matrices. So like at your level, you don't have to do this all the time, but in case you have to add, let's say like 2 columns. So you may have to do this, okay? 2 columns in the data set, maybe just do some sort of data manipulation. So these things could be helpful, okay? So let's do it. Maybe I don't have to do that. Let's do that. So we are creating 2 vectors here. The first vector has 1, 2, 3. And the second vector has 4, 5, 6. And then you add these 2 vectors. So let's see what happens. V1, it's right here. It's being created here. And you can clearly see. Okay. Now it's only showing V1. See? And then we are adding V2 here. And now we are adding V1 and V2 as V sum. So we should be able to see what V sum is. So you can see simply adding V1 and V2, right? 4 plus 1 is 5. 5 plus 2 is 7. And then 6 plus 3 is 9. Okay? It's simply adding them. So similarly, like you're doing it in matrix also, so it could be like a little bit complicated to visualize it, but it's doing pretty much the same thing. And that's the first one. It has only 2 rows, okay? And it doesn't have, it only has 1 column. So which is easier to understand. So if you add these 2, it's just going to be the same thing. So this is basically like one-dimensional matrix. It's actually basically another vector, right? So it's pretty much having the same form. So, but I wouldn't go like, too advanced, like, matrix calculations. It's not really necessary, but if anyone is interested, I have some activities for you here. We can also find the sum, mean, length of vectors. So using these commands. So, for example, so if you have these numbers that you want to find the addition, the summation, the total of these numbers, basically these numbers is actually stored, in a vector, right? You can see that. So just get the sum like this, and it's 50. And if you want to find the mean, you can do the same thing like this. And then if you want to find the length, that means the dimension, that's also going to be shown here, right here, 5L. That means the length is 5. Okay. And if you have two dimensions, it's, let's say like 5 by 3, then it will say 5L and 3W. W is the width, right? Length and width. So this is only showing length because it's one-dimensional. Okay. All right. So I think it's a little too much. And again, I have some print things. You can try this, at leisure. You don't have to do them right now. So try them later. Okay. All right. So let's move on to the next topic, control structures. So let's say we have to do something, repetitively. For example, we have to, add something like repetitively. Let's say like you have to add 1 plus 1. And then to that you have to add another one, right? Let's say this is what you have to do. 1 plus 1 plus 1 plus 1. So if there's something that you have to repeatedly do, you can see in the first step, you are adding, let's say initially we have, let's say only 1. Okay. Now in the next step you are adding adding 1 into that. And the following step you are adding another 1 into that. And then you are adding another 1 into that one. So instead of repeating the same thing, right, you can see we are repeating the same process. What are we doing here? Going from one line to the next line, just adding, right? Adding another 1. So since we have to repeat this, we don't have to type this repetitively. So we can use this like, loops and conditions to really get that done. So let's say we want to only add 1 if, the total is like, an odd number, or if the total is an even number, right? So here the total is an odd number, right? 1 is 1, right? And 1 plus 1 is equal to 2, right? And then 1 plus 1 plus 1 is equal to 3. So likewise, we can check the total, and if the total is like, an odd number, only you add the 1. Otherwise, you skip it, right? So it's just like, random, stupid example that I told you. But just to show you, when you put conditions and when you do things repetitively, so you don't have to write all those lines, like commands repetitively, like, 1,000 times. What if you have to do this 1,000 times? You cannot write everything, right? So that's where like these things become handy. So these if-else statements, and then the other control structures where we can loop. Okay. First thing is like we check, if and else. In day-to-day life, we use if, right? If this happens, we are going to do that, right? If I get paid, I'm going to buy that. It's the same thing, okay? If you can do this by this time, you can do that, right? So the same if and else. If you cannot do this, what else you can do, right? So if you get paid, you will buy this, or else that's another thing, right? It's the same thing, in computer, we use this programming language to tell computer to check if a condition is satisfied. If so, do one task, not do another task. Otherwise, okay? So that's why we have this control structures, and then we can combine them with loops and get things done. So you can see this is a conditional statement because it's a condition, right? It's condition, so the statement. So this is like the pseudocode or the script that we typically use. We put the if condition, if and then condition, and then only, let's say if this condition, we write it within this parenthesis after. If this condition is met, it will execute whatever within this bracket. Okay, so whatever you have within this bracket, it will execute only if this condition is met. So that's what it does. It's very simple. So it's giving an example here. So right here, so it's saying x is 10, right? And you are telling the computer if only x is greater than 5, print x is greater than 5, right? So basically, if x is not greater than 5, it's not going to print. So let's see if it's going to do that. Okay. So this is the command. So let's clear this. On it, and x equals 10. So if x greater than 5, print x is greater than 5, right? So let's try to print that. Yes, x is greater than 5. What if we assign x equals 2, right? So what would happen? Let's see. Now in this case, x is not 10, now it's 2. So it is not greater than 5, right? So it should not really print anything, right? So let's see. See, it did not print anything, right? So which is right. So computer did not make any mistake. Okay. So this is really simple, right? So you can see that condition. So but else if. Now else if is being used when the condition is not met. For example, we said like earlier, if x is greater than 5, you say x is greater than 5. If you also put like else if, you can say x is less than 5, right? So this is what that command is. So you can see if condition is met, it's going to execute whatever is within this bracket. Okay. Else if right here, else if you're going to do this condition to be executed if the condition 1 is not met, but condition 2 is met. Okay. So we have an example here. So let's try this now. So what does that say? So again, we are saying x is 10. So we are telling the computer if x is greater than 5, x is greater than 15, you print x is greater than 15, right? So that's what it's saying, right? Else if x is greater than 5, print x is greater than 5, but less than or equal to 15. So now can we try this and see what the outcome is going to be? What would that be? What would you get? In this case, x is 10, right? So we should be able to see, okay, what are we going to, sorry, I didn't assign anything. So x is 10. Now, x is greater than 5, but less than or equal to 15. See? That's what it's saying. Right? So what if I assign x is 15? What would happen? Did we put that condition? Yes. It's less than or equal to 15. It could also be equal to 15, right? So you can see, we can set all these conditions like this. If you want to do let's say if x is less than 5, you can also print that x is less than 5. So you can add multiple if and else if conditions like this. And then, whatever you put within this, this within this code, I'm sorry, these brackets, you can, it's going to run. You can have multiple things, like not just one print. Let's say you can print like multiple times, or add something. You can, let's say you add another number to X or something. So you can do multiple things within this bracket only when this condition is met. Okay? And if the condition is not met, it's going to execute something else. So these things become really useful when you run your programs. Okay, so I think that's enough for if else. And I have another example for you. Do I have another one? No, I think it's the same thing. Yes. Oh yeah, it has three conditions. See, else. So in this case, I have three things. So you can see, if X is greater than 5, you print X is greater than, sorry, if X is greater than 15, you print X is greater than 15. Else, if X is greater than 5, you print X is greater than 5, but less than or equal to 15. Else, print X is less than or equal to 5. So that means if X is less than 5, let's say in this case it's 3, right? So it should say X is less than or equal to 3 and 5. So that's what it did. Okay. Yeah. So if you, maybe for the first time when you do this, you might find it difficult, but I really would like you to spend some time, today or tomorrow, depending on the time zone, just to practice these things and put some different numbers and try to understand what it really does, and try to write it on your own. Okay, so it's really, it would be helpful. Again, in order to, honestly speaking, in order to like just run a code, let's say import your data set and then run a model and then get your analysis done. You don't need this directly, but if you do some extra calculation, extra work, you're going to need things like this. Okay, so if you have to modify things in your data or add some other conditions into your analysis. So in that case, this might be useful. But if you're just simply like running your model and visualizing, you probably would not need this. And then loops. So loops are still important because, for example, if you do things iteratively, you need to understand what loops are. So in loops, first thing is we just have a block of commands, lines of commands that are within this loop, which is going to run iteratively. So we have a for loop here. So for, variable in sequence. So for this range of values, just execute this. Okay. So when it does that, it's actually going to just repeat whatever within this this back brackets for this much of times. See, like you see, for I in 1 to 5. What does that mean? So that means I is a variable. It's going from 1 to 5. That means it started at 1, and then it goes to 2, 3, 4, and 5. So that means this loop will repeat 5 times, because we are asking you to repeat it 5 times through this. It's going to print 5 times, 1 to 5. Okay. If you do that, you will be able to see that. I'm using copy paste commands, in MacBook, so I forgot, it's a Windows computer. Sorry. All right. So yeah, right here. See, for I, in 1 to 5, print I. If you let's say 1 to 10, that's going to print up to 10. See? 1 to 10. So this is, you can also do multiple things. You can add something, you can subtract something, you can print something else. do another calculation. You can have a function, or you can also have your data analysis. Let's say you have to repeat your data analysis multiple times. You can put your analysis like code inside this loop. Then it will run it for 10 times. Okay, let's say like there's 10 samples that you have to run your code for, and then you just you put your code within this loop, and then it will run. You have to assign how many times you have to run. Okay, 10 times, 100 times, and it will do it. So this could be useful, for most of you, this kind of loops. Yeah. So now here we have a while loop. So this is a different loop condition. No, it repeats the block of code as long as a specified condition is true. So now we can see within the loop. So let's say while I is less than or equal to 5, you just do whatever is within this bracket, right? But within the bracket, we are also adding 1 to I, right? So it's going to increase iteratively. So that means, every time you go through the loop, it's going to increase its value. So when it reaches 5, after 5, it's not going to continue. So if you print this, you will, you will see the outcome. I'm going to show it to you. For while loops, they're doing the same thing basically. You can use either one, so that's fine as long as you know how it's being done. So I initially it's 1. So while I is less than or equal to 5, print I, and after printing I, you add another 1 to I, right? So that means I becomes 2 when you go back here. So once this line is executed, you're coming back here and you're checking what the value of I is. So the second time when it comes, I is 2. So still it is less than or equal to 5, and it will do the process until it reaches 6. When I becomes 6, it will not do anything. So if you run this line, you will see, and this command, you will see it's only going to print 5 times. All right. Yeah, so you can practice these loops later. And again, there's another activity for you. Maybe we can try this. I don't know. Maybe it's better if we try. Let's select one activity for us to try. We don't have to do all of this actually. Let's do a couple. Okay, so let's do if else. We can try this one, okay? So we are saying number is -5, right? So -5 is the number. So we are saying if number is greater than 0, print the number is positive. Else if number is less than 5. Else if number is less than 0, print the number is negative. Else print the number is 0. So you can just copy paste this command and change this number to different values and see if it's working for you. Okay, I'll give you a few minutes. Try that yourself, please. Hello, Verna, can you hear me?
Yes, we can, and we can also see your screen.
Okay, so I'm thinking, so I feel like we have covered a lot of things today. Do you think we should not like do like the next section because it wouldn't that be too much for everybody?
That would be,
So I don't.
I'm sorry, sir.
Yeah, I'm just thinking because I mean the next topic is function. So I don't know if others want to take some time to understand what we have already done, and then uh, resume this like this the remaining slides. I mean the rest of the work tomorrow. I don't know if that's what you want to do. It looks like it's too much, but if it's up to you, you can let me know.
I think, sir, that's an excellent idea so that we are able to give them some rest and also be able to practice. I think, though, for just an announcement, like Dr. Kasgola's slides are actually very easy to follow. So, if there are steps or processes or some activities that you have missed, I strongly suggest that you go back to the slides, start from the beginning, and make sure that you guys are able to get it. And if you have questions, like maybe we can begin tomorrow's session by questions. Is that okay, sir?
Yes, definitely. Yes, I would like to get any question. Please take some time and try to practice. Maybe for most of it, this could be a little overwhelming, but just do whatever you can. Just practice because all the lines are given, so you just try to copy paste and change the numbers and see what it's doing. I think if you can see and understand the basics, I think that's more than enough.
Thank you. And we will also try to send you the video for today's recording by maybe 8 to 10 hours from now. So we are time zone challenges. So we'll try to do that as early as possible. But however, we strongly encourage you to practice. And I will also try to give you the a copy of the syntax and uh some data sets that you might be able to practice during the weekend. So I know that it's like sort of back to back for 3 days, but we appreciate you being here with us, and we appreciate Dr. Kasgola. Thank you for the first day. So there will be few more sessions. We hope that you have learned uh we hope that you valued this session. And if there are any last questions or anything, otherwise we'll see you tomorrow. You're free to go. Thank you for staying the whole day, Dr. Kasgola. Thank you so
Okay.
much again. We'll
Thank
see
you.
you
Thank you so much.
tomorrow.
Bye.
Thank you.
You. See you. Bye.
Thank you, everyone. I'm gonna end the meeting now so that we can actually have the recording converted.